Right, good morning, everyone. Okay, how did your homework go? Do you have any questions about the homework? Please get going. Okay. Well, those seems like they were hard problems. All right, so we go through hopefully most of them. So let's start with number 20. Which section? Are they all section 3.3? No, that's 3.4, sorry. Okay, so number 20 is g of x equal 6x minus 2x ex. And the question is to find the derivative of this function. Okay, so that's now we're starting combining stuff. Some are product and some are sum and product. So we do them step by step. So this function and this one. Okay, the first one, derivative of 6x is 6 minus derivative of 2x ex. So how are we going to view this piece? We're going to view it as a product. So it's 2x times ex. Okay? So the derivative is going to be, open parenthesis, is the derivative of 2x times e to the x minus 2x, the derivative of e to the x. Okay, so let's do that. That's equal to 6 minus the derivative of 2x is a 2 e to the x minus 2x. The derivative of that is e to the x. And finally, I distribute 6 minus. Now, a lot of you, I was grading your quiz yesterday, you forget to distribute properly and you're getting into a lot of difficulties. So when things should simplify, they aren't simplifying with you. So be very careful with distributing. Minus, minus, it's a plus 2x ex. Okay, so that's the end of this. We do it very slowly. Now let's look at number 24.
Professor, I have a question.
Please go ahead.
For number 20, the answer, it doesn't matter if we put 6 plus 2x e to the power of x minus 2ex, or?
No, it doesn't matter.
Okay.
It doesn't matter, absolutely not.
Thank you.
Okay, so g of w equal e. So w is my input here, 5w squared plus 3w plus 1. Okay, again, we have to find the derivative of this function. So we're going to find g prime of w, or if we use the Leibniz notation, this should become dw, because that's the input of g of w. So that's either this notation or that notation. So equal to. Again, we have to recognize what are we dealing with. So now we're dealing with a product. So we apply the product rule verbatim. So it's the derivative of EW times 5 plus EW times the derivative of the other term. And now the rest is we find the derivative of the other terms. So the derivative of EW, that's EW. W is my input here. Plus EW. Now the derivative of this term, derivative of 5w squared is 5 times, so that's a 10w plus 3. Now at the end, we just combine the terms a little bit and then we proceed, okay? So let us combine them. I will get equal to, and you know, we are of course calculus 1, so I know I can factor out the EW and I can do this. So that will give me 5W squared plus 3W plus 1 plus 10W plus 3. So finally we get e to the W, and I will have 5W squared, 3 plus 10, 13W plus 4, okay? Now we look at number 41. Okay. Okay, 41. So we have the function g of t equal 3t squared plus 9 over t squared. Okay. Very good. So, I mean, there is no product here. So we are back to the previous section, but we have to use the previous section. This term is ready to find its derivative. This term is not ready to find its derivative. We have to rewrite it. So we have to go back to rewriting. So 9 over t squared, it's basically, no, 9 over t squared is 9 times 1 over t squared. Okay, so we have to rewrite it as 9. 1 over t squared is t to the minus 2. Now my function is ready to be differentiated. So now let us compute g prime. So now the derivative is equal to 3t squared, the derivative is 3 times 2t plus 9 to the power minus 2, t to the minus 2 minus 1. So finally, I will get 6t minus 18, t to the minus 3. And finally, you can either keep it like this, or because it's such a simple expression, we can rewrite it 18 over t to the power 3. Please ask questions as I move on if you have any difficulties. Can we use quotient rule for the quiz? No. Sorry, Nick. Okay, if I give you a problem along those lines, I want you to do it this way, because eventually that's way easier. That's way easier. Okay. But actually, I was planning to make a remark about this problem later on in the lecture. All right. So now number, where we are, sorry, 63. So let's look at number 63. Okay. So now the question is find the equation of the tangent line, and then they want us to graph the curve and the tangent line to make sure that our answer is correct. So here the function is y is 1 plus 2x plus x ex, and the point is a equal to 0. So we want to find the equation of the tangent line at this point, and then we graph everything. So to find the equation of the tangent line, we need two things. We need the slope of the tangent line, and we need a point on the graph. So we need to find the slope. To find the slope, I need the derivative. So first, we want to find the derivative. So dy dx equal. Okay, we change notation so you're comfortable with all of them. Equal to. Okay, derivative of 1, that's 0, plus. Derivative of 2x is 2, plus. Derivative of x ex, that's the product rule. So that's the derivative of x times ex plus x times the derivative of ex. So dy dx equal to 2 plus, because I had a plus, I don't have to worry about distributing, e to the x plus x ex. So that's the derivative at any point. Now I want the slope of the tangent at this particular point. So I need the derivative at the point x equal to 0. Or we can write, if you want abuse of language, y prime at 0. Okay, either notation is. So now I have to plug in 0 for x. So this will give me 2 plus e to the 0 plus 0. It means anything to the power 0 is 1 equal to 3. So that's the slope. So now I have two things. The slope of the tangent line.
I have a question.
I'm listening.
Where'd you get the 1 from?
E to the 0. Anything to the power 0 is 1.
Oh, okay. All right.
Any
Thank
number to the power 0 is 1. Any number. Okay.
Oh, okay. Thank you.
Are you with me? Yeah. So slope of the tangent line is 3. Now I need the point. The point is on the graph of the function, original function. So the point is here. So since it's at 0, so the second point has to be f of 0. Now I plug in the 0 back into the initial function because that's where my point is. I will get 1 plus 0 plus 0, 1. Now finally I find the equation. So the equation would be y minus 1 equal 3x minus 0 means y equal 3x plus 1. And that's the equation of the tangent line. Okay. Now they want us to graph it, so to make sure that we are doing it correctly. So it means whatever the graph is, we should have, and we will graph it, of course, in a minute. So the point is 0, 1. That's the point. And the tangent line 3x plus 1. That's the tangent line. It means at this point, the function should look either like that or like this, one or the other. That's what should happen at this point. And the rest, we really don't know how it is yet.
How did you get y prime again?
This one?
Yep.
Okay. What's the derivative of 1? We do it step by step. That's the 0. Plus, the 1 is a constant. It doesn't change. So its derivative is 0. Plus, what's the derivative of 2 times x?
It's just
Okay.
2.
What?
It's just 2.
It's just 2. With me? Now, this is what?
X times e to the x.
So what do you see in this? What's the keyword before you find the derivative? What do you think the word I'm looking for? Product.
Oh, product, I guess, yeah.
Okay, product, because we're going to have a lot of rules, so we should know exactly what is it we are, what form we have. Here I have a product. It means the multiplication. It means one function multiplied by another. So the product rule tells us what? Remember the product rule?
It's for like two functions f and g. It's f prime times g of x plus g prime times f of x.
Right.
Is equal to.
Exactly. Am I using it correctly now? Derivative of x times ex plus x, the derivative of ex.
Okay.
Fine. Now I move
yeah, that
down.
makes sense.
I will have 2 plus derivative of x
Okay.
is 1.
Okay, that makes sense now.
Okay, thank you. All right, so now let us just graph and make sure our answer is correct. So I will share the screen with you, and what should be here? And okay, give me a second. I need decimals as usual. I mean, decimals is great to graph. And so my function is 1 plus 2x plus x ex, and my, according to us, and now we will know at least whether we're right or wrong, plus 1. That's exactly what's happening. So we can see very clearly that the red line, of course, is the tangent line, the green line is the curve, and they definitely are, looks like a tangent line. And if we zoom in, you can see that as the more we zoom in, you realize that the tangent line and the function are almost identical. The more you zoom in, the more the function look like its tangent line. It means the values that the function take and the values obtained on the tangent line are going to be very, very close to one another. The more we zoom in, the closer they are to each other. Okay. Right, so we look at the last problem you guys have, which is number 78. What is it about? 78. Okay, so here they give us a table. They give us a table of values, and they want us to find the derivative with respect to x of the following function: x times f of x evaluated at x equal, let's see, x equal to 3. Okay, so before we even look up values, because I can't look up values, I need to find the derivative. So this is my function now, x times f of x. So that's the function I'm interested in. I need to find the derivative of it at the specific value x equal to 3. So how do we handle those type of questions? Step number one, before I do anything, I have to figure out in general for every x, what's the derivative of something like that? So before I plug in, I need to find the derivative of x times f of x for any value x. We don't plug in first. First we find it for any value of x. So this is equal to 1. That's the product. One function times the other. So I'm going to use the product. Remember, that's nothing more than a notation for the derivative. In other words, another way I could have written this is x f of x. So that's another way you can write this. Okay, so it's equal to 1. It's the derivative of x times f of x. I'm using the product rule, plus x times the derivative of f of x. So we don't plug in first. First, very slowly, we find the derivative for any x equal to. The derivative of x is a 1 times f of x plus x times the derivative of that is f prime of x. So now I found the formula for the derivative of this function, this one, x f of x, for any value of x. After I do that, now I want to zoom in at x equal to 3. So now I plug in what's happening at x equal to 3. At this stage, I plug in 3 for x. Now 1 is 1. So this will give me, I plug in 3 across the board, plus x 3 times f prime at 3. Now I go to my table and just pick up the values. There is nothing left to do. Okay. Now, according to the table they give us in the book, f of 3 is, so we have to be very careful, pick up the correct value. According to the table gave me f of 3 equal to 3 plus 3 times. According to the table, so at this stage, I'm using the table, so you know where I'm getting my values from the book, and then f prime at 3. Again, f prime at 3, according to the book, it's equal to 2. And this will give me 3 plus 6, which is 9. Okay, so those are nice problems, absolutely nice. I was planning to give you those on your quiz today, then I decided for next Friday. So those are very nice problems. So first, you find the derivative for any value of x. After you do that, you zoom in at the point that you are interested in. So we don't skip steps. We do it slowly. Okay. Is there any other questions? So
with any problem like that, you're gonna want to basically write out like the x prime times f of x plus x times f prime of x, and you're gonna want to work with that before you work with any actual values.
Absolutely. Any other way, you will have a mess. It will be wrong. Yes. First, for any x, then you plug in your value. Otherwise, you will be. It's wrong. Period. Okay. Crucial. All right, so for the next 5 minutes, I'm going to mention the quotient rule. So you guys go home with the rule because it's easy. So I will have to do only one problem and proceed. What is the quotient rule? So what we've done so far, we learned the derivative of basic functions, and then we're combining them. So we combine them by adding them, and we knew what happened in this format for the derivative. Then we combine them by multiplying them, and we learn the rule, what's the product rule. And we can combine function by taking one and divide it by another. That's another way of combining function. And the question is, what's the derivative in this format? So that's what we call the quotient rule. What we call the quotient rule. So what is the derivative of if you have the quotient between two functions? And these are formulas you have to, memorize, because as long as you are a student, you're going to be using them. So this is going to be equal to, so that's the formula, the derivative of f multiplied by g. So the numerator times the denominator, derivative of the numerator times the denominator minus the numerator, the derivative of the denominator, the whole thing divided by g of x squared. Okay, so that's the formula. We're gonna apply it to one function. So for example, suppose I have a function, I'm gonna call it h of x. And my h of x equal, I make up anything. Suppose I take, let's see, x cubed and over ex. Okay, so this is exactly this format. This is my f here, and this is my g. Okay. And the question is, find the derivative of this function. That's the quotient rule, so we have to use the quotient rule. There is no way out here. Quotient. Okay, so what does the quotient rule tell me? H prime equal, and I will use it verbatim. The derivative of the numerator times ex minus what? Minus the numerator times the derivative of the denominator, the whole thing divided by the denominator squared. So that's the setup, okay? And now it's just, we find each piece by itself. The derivative of that is 3x squared times ex minus x cubed. The derivative of ex is ex itself, divided by, okay, ex squared, if we use the rule of exponent, you multiply the exponent, right? So this is e to the 2x. Okay, that's the rule. And now we're basically done, but we can do a little bit more if you want, but we're actually done. I can factor out my ex, which will give me 3, actually I can factor out more, over e to the 2x. Okay, and if we remember, so remember our math a little bit. I'm gonna so that's ex 3x squared minus x cubed, and e to the 2x. I mean, I will accept that, but let us push it a little bit further. I'm going to rewrite it back as ex squared, and now I can simplify. I can simplify, so this will give me, those two will simplify. I will have 3x squared minus x cubed over ex. Okay, so that's the quotient rule. Basically, it's a rule, you memorize it, as simple as that, and then we apply it verbatim. And you will have problem like before, you know, slope of tangent line, you know, when the slope is horizontal, and so on and so forth. Okay, so for Monday, basically, you'll have problem what you have to apply the quotient rule, and probably, of course, every time we learn one new rule, we use it, and we use the one that we've learned already. Okay, any questions before we start the quiz? Okay, so please, you know the rules, go to your quiz and get started. Sorry to interrupt you. Question number one, I don't want you to use the rule. I want you to use the definition of the derivative. It means the limit, not the rule.